It's a real pleasure and it's a real honour to be elected as the 105th President, and I feel I'm amongst family. My direct family's here, but from the inception that I was made, I think, a student member of iStructD, I felt part of the family. So I'll try and give you a little bit of insight into my career, I guess my journey with iStructD, talk briefly about the history of iStructD, because obviously with 118 years, I want to just highlight some of the key issues, particularly looking towards the future, and talk about the presidential themes that I've chosen this year, which are very much aligned to the new strategy, which many of you would have seen in the last issue of the Structural Engineer. So a little bit about my past, present and future, which I mentioned. As I said, a bit of a whirlwind tour of some of the significant issues that iStructD has had to deal with over its 118 years. And the presidential themes which I've chosen for this year, registration and supervision, but perhaps mentoring is also a very good way of describing what I would like to concentrate on in that particular aspect. Embodied carbon, and obviously dealing with climate action in the built environment, has been a very important theme of previous presidents of late, and I'd like to continue on with that and maybe highlight a little bit of the effects of structural efficiency in that particular theme. And then technical competence and research. We've had a lot of discussion actually today in today's council meeting about technical competence, and I'd like to be able to work with members this year to shine a light on that, and perhaps what do we mean by technical competence. Obviously, in any discipline, one can't be competent across the entire area, but how is that related to individuals in the practice that they're practicing in. And I guess in my little way this year, the presidential themes, how they interlock with the iStructD and its new strategy, and hopefully I can meet as many people, whether that's face-to-face this year or also online, because there's a number of activities and visits that are planned this year. So in terms of my personal journey, I was born in 1970. A Dutch mother and a Chinese Filipino father who met in Sydney, and this is during the time that the Sydney Opera House, that many of you will know, was under construction. And for those of you who've been to Sydney or seen photos of Sydney, the Opera House is juxtaposed by the Sydney Harbour Bridge. So the reason I mention those two elements is that concrete and steel have played a really important role as part of my entire academic and professional career, and it's really hard living in Sydney to actually ignore those two important construction materials which have been so useful during our age. Unfortunately, my father passed away when I was quite young, and my mother, being an only child, we moved back to Holland to live with my grandparents for a number of years, so I started school there. Those were some of my early days in schooling. We returned back to Australia, completed primary school and high school, and then I started a civil engineering degree at the University of New South Wales. And I chose to major in structural engineering and engineering construction, and I was fortunate during my final year of my undergraduate studies to work with Professor Mark Bradford, who's a fellow of the institution, and he got me very interested in research. I had a research project working on steel and composite construction, post-tensioning of those systems, which even when we look back those 30 years ago, it was really looking at how we can actually increase the life of infrastructure. So very much the issues that we're dealing with today in trying to reduce embodied carbon and make structures last longer. He then was very persuasive, even though I did have a consulting position. He was very persuasive in taking me for lunch and trying to encourage me back to do a PhD. I did graduate during a recession, so I should say that I was essentially very interested in structural engineering of buildings. During a recession, as most people know, there's not many buildings being constructed, so He was very successful in encouraging me back, and we actually worked on this particular project where, I'll just get this laser pointer working, what we were actually looking at in this particular project was, and most of you would be familiar with cold formed steel decking for slabs, but in this particular system we were also using it for beam systems, and there was quite a number of projects in Australia at the time that utilised this concept. But the important part in this PhD project was really to develop some really fundamental skills. I was able to develop skills in buckling, long-term behaviour of concrete and composite behaviour, and really set me up for important initial entree into academia. We were able to publish quite a number of papers, including in the Structural Engineer when research was actually published as part of the Structural Engineering magazine. So moving to perhaps my involvement in iStructD. In fact, in my final year of my undergraduate studies, Professor Max Irvine, he was a fellow of the institution, and he, as many of us do when we're trying to encourage undergraduate students, passed out the registration forms for student membership, and I guess I was interested and got the magazine regularly. And in fact, I joined the New South Wales division of iStructD the next year. So I've been involved with iStructD for well over 30 years, and again, felt very much like I was brought into a family. We had a very good and chairperson, Charles Rickard at the time, who really encouraged us, and a number of undergraduate students are still serving on that committee to today. Then I obviously took on the Australian chairman's role after I'd served as a vice chairman, and this is when we established a Australian regional group back in 2008, and that was where we actually looked at each of the states of Australia and made it a little bit difficult before the days of Zoom and Teams meetings, but we always had an annual face-to-face meeting as part of that initial Australian regional group, and that's still very active till today, and we have our chairman in the audience today, and that was a really good regional group to be a part of, and really able to achieve fellowship, and then sought and was able to become a vice president of the institution, serving the entire Australasian and Southeast Asian region, and many of the members here represent those regions. So if I just focus a little bit on how I think I was so interested in civil engineering as a career, I had a very supportive grandfather who was very much involved in painting of large infrastructure in Kurnell, which is a part of Sydney. It's actually where Captain Cook first landed in Australia. And certainly that was a very important mentor in my early days. My cousin Kos Caverna, he's part Peruvian, part Dutch, and he was working on North Sea platforms as a hydraulics engineer, would often send me magazines and write to me about the projects that he was involved with. So he was a very important mentor in my early days, as was my next door neighbour, who was an architect. But this was a slightly different mentor. He was an architect, and I actually was thinking about a career in architecture, but he was actually really encouraging me to become a civil structural engineer, because he had seen the peaks and troughs of the building industry, and even though he would have liked to see me work in the architecture field, and those lessons are quite important, because obviously being in academia and trying to assist high school students with their choices in careers, where often parents are very much interested in the career prospects and the ability to have gainful employment. That I think was a very unselfish act of him at the time. So moving back to some of my influences in my PhD, Mark Bradford, who was a fellow, he was my supervisor at the University of New South Wales, and Derek Ohlers, who was at the University of Adelaide. Well, I had a PhD which straddled between Sydney and Adelaide. I did a lot of my experimental work in Adelaide, and Derek was a really important mentor who was very skilled in experimental setups, and also trying to come up with simple solutions to describe quite often complex phenomena. So they were important mentors. When I graduated from my PhD, Howard Wright, who was the department head at University of Strathclyde, invited me over. I spent quite a number of stints with him and his team at the University of Strathclyde in Glasgow. And also, many of you will remember the late Professor Shane Mugham. He also invited me over to work with his team at the National University of Singapore. For many years, he was the Singapore Regional Group Chair. And again, some more mentors, and so delightful to see David in the audience. He was very helpful in my early career in academia. In fact, I spent some time with him more than 20 years ago for 6 months at Imperial College. And what was even the most, if you like, effective and really helpful part of that is David introduced me to a wealth of people that ex-students at other universities in industry, and that really set me up for a career in the profession. I really thank him for that particular mentoring role. Roberto Leon, who's also in this photo from the US, spent quite a lot of time working with him on the ASCE and Structural Engineering Institute composite standards. And we've just heard about this gentleman. He's been extremely supportive this year, Mohammed. Despite his busy role as the president, as well as having a really important and very demanding role in Dubai, he always found the time to reach out to me through WhatsApp or email, and after or before board meetings, and I really thank him for the support he's provided. Some academic mentors, Professor Aryaratne, who you'll probably hear from in a number of videos that the team has prepared through all the work by Nabila and her team. Professor Alex Romanikov, who you'll also hear about, we did a lot of work on critical infrastructure protection, and probably my most supportive supervisors over my career, Professor Hesketh and Professor Archie Johnston from the University of Western Sydney and Sydney, respectively. So I think this video is just going to provide you with a little bit of insight from both mentors and mentees about some of the activities that we've carried out throughout.
I first met Brian in 2013 in Melbourne. We struck up a very close relationship. Brian has been a great mentor to me. He's extremely generous with his time.
I have seen him mentoring the others, how he handles his staff, the young professors, the young PhD students who he supervises.
12 years ago, I worked with Brian at the University of New South Wales as one of his postdocs. He always inspiring me. Everything you do need to be practical. You need to have the real application.
I met Brian when I was studying in University of New South Wales. So he was my lecturer. When he supervised me, I see how he supervised students and how professional he is. Then I'm practicing the way he is right now.
When I was at uni, I found him very engaging, very knowledgeable, and of course he was driven and passionate about the topics that he taught, which you could feel translate through to his students. He was one of the reasons why I continued to practice in structural engineering, because of enjoying the subjects that I learned at uni through him, testing and pushing the limits through experiments and research.
He is all the time talking to people. He is not only confined to Australia. He's an international guy. He's there, he's everywhere.
Every step of my career, I ask him for advice. And even now, when we're doing research and all those things, he will still always check on me.
He has that craving to do things. So he will bring new ideas to institutional structural engineers. He thinks outside the square, bring those ideas, and he won't be shy to put those ideas.
So thank you to all of those people who spent an inordinate amount of time working on that. But just getting back to some of the aspects of my career, I guess I could have this acronym for my career, which has started in practice, predominantly in academia and standards, but really supported and by strong teams. So I spent time as an undergraduate structural engineering working for Morgan Chapman and Partners. They were designers of the Sydney Tower, and in that particular area of practice, I predominantly worked on one major building, which was a university service building. But the key aspect for this particular project was to, as a junior engineer, to work on pretty much every aspect of structural engineering for new construction, being reinforced concrete foundations and slabs, and structural steelwork for the roof and frame, and also masonry walls. So it was a very good project to work on. Then when I graduated from my PhD, I was actually working in the oil and gas industry. There was really only work as a structural engineer in the oil and gas industry or the mining industry, which tends to happen particularly through recessions. And again, working on converting oil rigs to gas through deck side modifications, and what appeared a fairly mundane role at the time, but really inspecting videos for sacrificial anodes on offshore steel structures. So I'll come back to this later, because there's some more recent work we've been doing on offshore structures in Australia, which might help complete the loop of what other aspects of my career. I also was involved with this project for BP Solar, and this was one of their first projects in looking at photovoltaic arrays in some of the most cyclone-prone areas of the Pacific in Solomon Islands, up to about 250 kilometres per hour. When I completed my PhD, I had a short stint working for Arup in Sydney on this project. It was a Star City casino, and again, had a really supportive team of supervisors, Bob O'Hay, Rob Hale and Umesh Rajakaraya. The interesting part of this project, I had a number of opportunities, but this particular project was involving the use of a lot of concepts and materials that actually weren't currently existent in the Australian standards, which were used for construction of buildings in Australia, using high-strength steel and composite techniques. And since this project, we've been able to, if you like, codify some of the approaches. And so it was a very interesting project to work on. And these are some of the drawings, I guess, from some of these very large span steel and composite beams that we were involved in the design for. I guess my major part of my career has been working in academia, and I've worked at 4 universities, predominantly in the Sydney area, 14 years at UNSW, 10 years at Sydney, 7 at Western Sydney and Wollongong for 7. And as I mentioned before, I was fortunate to have fellowships at National University of Singapore and Imperial College, as well as during the pandemic, when many of us obviously weren't travelling. I was fortunate to work with University Kebangsaan Malaysia, and both in a teaching and research capacity, which was a very interesting activity. Standards has been an important part of my career for close to 30 years now, and I've been fortunate to chair the Composite Buildings Committee, and I work very closely with a New Zealand colleague, many of you will know, Professor Stephen Hicks, who now is back at University of Warwick, and we worked on this particular document, which completed in 2017. And Stephen actually chaired the Bridges Committee for Australia and New Zealand standards, and when he returned to the UK, I have taken over this particular role. So there have been, obviously these 2 standards have a lot of similar concepts in steel and composite design, and I guess the major issue is looking at some of the fatigue aspects of the bridge standards. I think this is a short video on some of the standards work that we've done together.
Brian and I have worked collaboratively in a number of projects. We both chaired the first harmonised standards for steel construction for both New Zealand and Australia. And we worked together actually to create that harmonisation to remove some of the barriers of trade between the two countries.
Brian has been chair of composite standard for many years, and he also well known with other international standards as well. So it's easy for him to make a case that we need to improve our standard with international practice.
I want to do something that changed the society. So I was lucky enough, he had a project working with industry, it's a blue scope steel, and there I was the one who helped him during my PhD to minimize the concrete, you know, in a design. And then also like after a few years, our research actually has been augmented into Australian standard.
The steel and the concrete design standards started to use high strength materials, so high strength concrete up to 100 megapascals, high strength steel up to 690 megapascals. And at that time there was no real international standard in composite construction which used those two materials. So we worked together in terms of developing design rules which was based on research activities that we've both done, design provisions for composite columns, and that's probably one of Brian's areas of expertise. And one of the unique things we did from that was in many of the European standards until that time, most of the provisions were based on historic design rules. And because we had the opportunity to write these new standards, we basically used structural reliability, which is one of the first times it's been used all the way through a new standard, because we had that uncertainty whether or not the same margins of safety would be delivered with these high strength materials.
I have gone through most of the bridge design codes of the world. Ours AS5100, which is for Australia and New Zealand, is one of the best and most comprehensive. Brian and myself, we were recognized for being members over 25 years with Standards Australia. And it's a voluntary thing. In addition to our work, he gives his time. Person of that caliber, time is precious. But in spite of that, person to give your own time is rare these days, and it should be valued.
So thanks to Ari and Stephen. But I think the key message there, particularly with standardisation, is being able to work in an effective team. And I think that's the thing that's really underpinned a lot of the work that I've been able to do, particularly in standards, universities, but also to shine a light on the work that I've been able to work with the IStructD, both the Australian Regional Group and now the board. It's been a real pleasure. As I said, it feels like we're part of a family working together to achieve the mission of trying to improve the profession of structural engineering. I can't go without mentioning my family, and I really thank my family for being able to join me here today, and not only that, to mention the great support that they have provided me over my career. And I wanted to shine the light on volunteerism in general, because essentially our whole iStruct, well, not all of it, we've got a really great team at HQ, but a lot of the work that we do in committees and so forth, many of you here tonight, in fact all of you, you understand the strength of volunteerism, and I think we need to thank our families for that. So very happy to share this with my wife Shane, my son and daughter Carrie Mariah, and also our 2-year-old border collie who's back in Sydney unfortunately, but we're looking forward to seeing her again soon. Obviously it's an immense pleasure to carry on this role for this year, and I do that in conjunction with my role at the University of New South Wales. I also serve as Vice President of IAPSI, and I'm trying to look at Mohammed's, take a lead from Mohammed to try and create greater collaborations between our organisations, and I mentioned standards before. It is also a great privilege to teach undergraduate students, and in fact I still teach in steel and composite structures and bridge engineering. I'm going back to Sydney after this in a few weeks' time to teach over 500 students in steel structures, but it's a great privilege to be able to do that, and I've been trying to, again, some of the message that I want to talk about today, instill that in some of our undergraduate and postgraduate students. Research is an important part of my current and future activities. I'm really fortunate to have some of my previous postdoctoral staff here in the audience today, and some of the work that we've been doing on low embodied carbon systems, steel reuse, and also looking at new structural steel systems for nuclear facilities, which is an important issue in Australia in the future, particularly for defence and also potentially power capability. And which brings me to, again, some of that research work, translating that back into standards. I talked about the composite buildings and bridge standard, and this is where it comes full circle. So I started my career in offshore structures, and more recently our Australian government is looking at decommissioning the Australian offshore industry, as I'm sure some of these things are happening also in the UK and Europe. And I was part of a group from the Academy of Technological Sciences to look at how we can utilise some of the existing infrastructure in the offshore industry. So there's about 5.7 million tonnes of structural steel in Bass Strait, which is equivalent to about 110 Sydney Harbour bridges. And so we're now starting to look at how we potentially could create an industry for reuse of structural steel. I see there being a very important role in the future in Australia and New Zealand to then follow some of the recent standardisations for net zero carbon buildings, which iStructE has been leading, and also our colleagues in the US. And I think Andrew's watching, but Andrew Whitaker, who chairs nuclear facilities standards in the US, we've been working very closely with them because we're about to have a number of defence facilities, mainly nuclear submarines, where we need to develop standardisation for local builders. But it's not just for defence, it's also for power facilities in the future. So moving back to our fine institution, and I can't give it justice in this short period of time, but obviously a 118-year institution. Let's look at some of the past, present, and let's also try and focus on some of the future aspects. Many of you know, it started as the Concrete Institute in 1908, became the institution in 1922. I've chosen this aspect because it's quite, personal. Florence Mary Taylor was the first female elected in 1926, and we were actually fortunate in 2007 when Dr. Sarah Buck became the first female president of iStructE. She visited with the then CEO, and we were able to actually organise a showing of a portrait by Florence Mary Taylor, who has a very significant role and played a very significant role in Sydney's history. So not only was she an architect and an engineer working in the Sydney building industry, she actually published a magazine, very much like perhaps the TSE is today, about trying to shed light on new technologies in our industry. Obviously the Royal Charter in 1936, the 11 Upper Belgrave Street, which many of us will remember, in 1938, and the first structural awards in 1968, which I think was the first Severn Bridge, which I drove over the other day. I mentioned Sarah, who visited us in Sydney as part of her presidential tour, and many of us obviously remember the centenary in 2008. So a very significant moment for the institution, and many of the people who were involved in that important decision. The new headquarters purchased here in 2013, and the move to here after the renovations in 2015. A very important step for the institution, the engineers declare in 2018, and obviously I think it's not an understatement to say that iStructE is really considered to be a world leader in the sustainability throughout the world in structural engineering. So whether it's in Australia, New Zealand, the US, many of the countries that I have visited in my career, they all point to the excellent work that's been done at the institution. Which brings us to the new strategy, which has just been released, and our new, not new, but our current CEO, Yasmin Becker, that was published in the last issue of the TSE, and I'll spend a bit of time just trying to focus on some of the relationships between the new strategy and some of the themes that I've chosen. I've tried to forecast by decade some of the key issues that might face us in the future. So in 2030, it's mooted to be 1 in 6 of us will be at the age of 60, including myself. And I guess if we're looking at the future, we're going to see the need for infrastructure, buildings, the whole built environment to really take that whole issue into account. So I see that as an initiative that we really need to be thinking about. Many of us have heard about Moore's Law and the constraints on power, and I'll come back to that in a moment. We also obviously know about net zero emissions in the building, or not just the building industry, for the entire community, but we will play a very important role in that. But I guess coming back to this concept of, and I didn't want to mention AI, and this is really all I'm going to mention AI about tonight, which is really the massive increase in power demand that's going to come from AI in the next decade. So some of you may have seen this, but the demand for power internationally from now till in 10 years' time is going to be quadrupling. If we look at the typical power for an average sized country, the UK and Australia have very similar amounts, 300 to 400 terawatt hours. So that's currently the world demand on power, and that's going to quadruple. So that's going to have a significant effect, and obviously there's going to be a number of issues that are going to, where structural engineers are going to have to play a very important role, including in some of the very large loads that are required for designing data centres, but also perhaps the issue of trying to achieve net zero with that increase in power. So coming to the presidential themes, and as I said, the three that I've chosen for this year, registration, supervision, structural efficiency, embodied carbon, technical competence and research. But I've tried to align this with the mission and the strategy that the iStruct-E has released through the leadership of Yasmin, and this particular strategy has been a really consultative process over many years through council and also the entire membership. The three key pillars of advancing the profession, supporting professionals, and enhancing professionalism can be tied to these professional themes. To my presidential themes. So we actually had some discussion about this today at council, and the whole issue of registration. We know that it exists in the UK. There were some suggestions that this, it's important to see this broadened. We're actually currently tackling this in Australia. We currently have registration in Queensland, Victoria and New South Wales, and Engineers Australia is pushing very heavily for government to create a federated registration scheme. For a number of reasons to get this consistency, but there's also very large cost disparities across the country. And we were able to achieve this before in the health sector, and I think we'll start to see some movement. And so part of my role that I'd like to see in travelling and meeting with as many people around the world is to see how registration exists in those countries, and trying to support that by looking at the areas of best practice around the world. Supervision or mentoring, we've talked about this a lot, particularly in council, and how we should be looking at the mentoring role. I've often said potentially mentoring a mentee should be maybe part of our CPD. So it's not a mandatory issue. Is it something we should be considering to take away perhaps the conflict of interest that exists with an employer? And we might look at other models that exist. There's many other models that exist in the health sector and so forth. That's something I'd really like to raise. And with the end goal just being that we really want to improve safety in our industry. And that leads to CROSS. Obviously, many of you will know CROSS, which has existed for many decades already in the UK. We were able to set up CROSS Australia with the leadership of Mike Fordyce, who was the past president, and also Colin Caprani, who's here, who's led CROSS Australia for many years, and also in CROSS US, and I believe CROSS also exists in South Africa. Now that's largely a retrospective system, so potentially the concept of mentoring and supervision, can we create a proactive system so we have both there to look at safety enhancing professionalism for our industry. So I think, and this is really to avoid, when things go wrong. I've had the unfortunate experience of being involved in a number of legal cases, particularly where there's been deaths. And sometimes, as many of you would know, because of the settlements of a particular case, we don't get to learn from those issues. So I guess we want to have a system potentially that is proactive, where this doesn't potentially happen, and we can reduce the amount of fatalities in the industry. Moving to structural efficiency and embodied carbon in particular, I think we've had a large emphasis over a number of decades in terms of looking at material behaviour, whether it's geopolymer concrete, high strength steels. There's a large emphasis now on using timber and other materials to try and reduce embodied carbon. But really, should we be going back and look at the system behaviour and not just the material, the system itself and the concept? We've been doing a lot of work in our group at UNSW, and particularly with concrete, we've been using the term that tension is embodied carbon. So if we can design and conceive structures where, particularly for concrete, the compressive only structures, we can probably do a lot more than we currently are in just looking at the material behaviour itself. And that brings us brings us to structural steel and reuse. And we actually had a very good discussion about this today in council. And we about a decade or more ago, as the outcomes of one of the conferences I attended, there was in fact, it was Professor Roger Johnson who proposed that we should be really looking at how we design steel and composite structures for reuse. And so many of us were working on that, and more recently there's been the EPDs, if you like, published on this issue. So the key figures here, if we look at hot rolled, let's say that's 100% embodied carbon, recycling, for many steels, about 42%. But if we can have an industry where we reuse steel, we can get down to about 1%. So some of these issues I was talking about in reusing structural steel from the offshore industry or other industries, if we can do that, we can really make a big saving on embodied carbon in the built environment. And we obviously will need to develop standards for that. The other aspect is we should be promoting that excellence in practice, and really this is done in a stellar form by our institution. This particular building, many of you have seen it before, the Quay Quarter Tower in Sydney. This was featured in the TSE, but this involved probably utilising about 85% of the existing concrete core, and it was also shortlisted for the Earthshot Prize, which Prince William is the patron for. And being able to promote this excellence in practice. So I look forward to being able to meet with people and trying to see other projects around the world that are also pushing these boundaries. So there's a short video here on some of the thoughts.
There are just so many angles to incorporating sustainability into design. You're really able to challenge how design standards or design codes are written. There are no wastages in our design, so that every structure that we design is in its best form, its most sustainable form, to reduce the amount of embodied carbon. Could be trying to reuse an existing building as much as possible, building in front of an existing building and maximizing the area. And they're all championing sustainability in their own way, making sure that the future engineers are very conscious that sustainability should be leading their design.
For structure engineers, we can design the same structure with different solutions. Each person have different knowledge. The more knowledge you have, the better understanding you have for the structure. You can design very, very optimized structure with very small section.
Life cycle analysis is very important, because you not only looking at the material is green, what happened after use? Can we recycle it?
I'm really looking forward to Brian's presidency. I know that he will continue the commitment of the institution into the sustainability. We must recognise that the institution as a global footprint can't only respond to the huge advances made in sustainability in the UK, but we have to be cognizant of how we can most effectively increase sustainability in structural engineering globally, but we must take that leadership role into the more than 110 countries in which we have members.
So I think that's an important message that in each of our jurisdictions we will treat it differently, and we really need to recognise that. But I guess trying to promote areas of excellence around the world is really important in that particular domain. So finally, moving to technical competence and research, and in fact we had a discussion at this council today as well about technical competence and what that would mean. In fact, I guess we're fortunate as an institution. We have a mandatory CPD scheme, which is obviously a really important initiative. And technical competence and research is something that can actually even further advance that. So, I've spoken to many of you about, that you should be taking advantage of the resources, and many of you do. So you'll recall that when the TSC, Structural Engineer, did split off, and there was a journal, a research journal, Structures, that was that spun out of that. And that is available to all members free of charge. So that's a way of trying to interact with the existing research. I guess the other important initiative in terms of research is, as an academic, we often get criticised for just doing esoteric research that is not informed by industry. I think we really need to bring those two parts, or three parts of industry together, whether it's academia, consulting, and also some of the material suppliers, to really get an understanding of what the needs are for the future. So I was fortunate last year to chair the Engineering Leadership Group, and they're also working on that as the Structural Futures Committee to look at trying to bridge that gap and trying to understand what the important areas of research are for the future. So I mentioned the journal, and certainly would encourage people to try and take advantage of that, which again will help to raise and advance our profession. Thought leadership is another aspect of the supporting and enhancing professionalism. And in my role this year, I'd like to also continue on with some of the initiatives that Mohammed has had in his presidential year. One of those is collaborations, and I know last year Colin Caprani was able to have a joint meeting between iStructD and the Joint Committee on Structural Safety, and there'll be other important groups. We've always had a very strong collaboration with the American Society of Civil Engineers, the Structural Engineering Institute, and I'll be looking for ways that we can further advance some of those collaborations. I think this might be the final video before I wrap it up. This is really trying to focus on some of the research and
Points of real interest for me in Brian's presidency will be his focus on technical competence. I think as an institution, when we really engage with the increasingly advanced knowledge that's being generated in this field, that we are going to continue to grow as a profession.
I was with the transport, and Brian was with University of Wollongong. I like research and to know more, and I knew that if I work with the universities together, I can tap that knowledge and we can move forward. And that is how I met Brian. We worked on Sydney Harbour Bridge and Ansett Bridge. After what happened in September 11, the cable stayed bridges, the problem was the anchorage. And then we had a joint venture project. How do you protect them for blasting loads, particularly the anchorage area, which is exposed. Brian and his team worked on that and came up with the solution, and we had not one bridge, we had a family of bridges. So once the solution was found out for one, that was applicable for the whole family. So that was a big achievement.
I've been involved in many projects and research in the area of explosion explosion engineering, blast engineering. And one of my first major research projects in this area was with Brian. Since 2004, when he joined University of Wollongong as head of school, so we started working closely on the joint projects. Brian was well established at that time in terms of research grants, research funding, publications. We were successful in securing a large infrastructure grant to develop this unique facility, which is called National Facility for Physical Blast Simulation, to do blast experiments without going to the field, which is very visionary. At that time, there were only maybe 2 other facilities in the world of this kind, both in the military environments. He managed to bring some people working together from different fields, civil engineering, mining engineering, developing teams.
One of the areas of research we worked on was reuse of still members. There's not always all the information is available on where that product was sourced and the mechanical properties of the material. So exploiting structural reliability analysis, we developed some rules in terms of the minimum number of tests to verify the mechanical properties of the material, which could be used in design to deliver a particular safety factor. That was probably a little bit ahead of its time, and working on the structural Eurocodes at the moment, that's one of the initiatives where there's a technical specification under development on the reuse of steel members, but we did this several years ago.
Brian has a vision for the near future and distant future. He works in the direction of achieving the goals.
He is bringing a lot of value. He is all the time looking for new things. He's looking for new ideas.
I think he prides himself in actually being practical and actually speaking to practicing engineers and trying to solve problems for them.
So I think the key message there is I think we really need to work together, whether it's academia, industry, material suppliers, consulting. I think that's the way we get the best outcomes. So I guess I've tried to shed a light on some of the themes I'd like to focus on this year. And I guess now is the invitation for all of you and your teams to contribute and participate this year and the future. So I ask, how are you and your teams going to manage registration, supervision, mentoring, improve structural efficiency and embodied carbon in the built environment, and enhance technical competence and engaging with research? And I look forward to meeting as many people this year and engaging with people this year to see how you're engaging with these aspects, and hopefully we can shine a light on that and drive some of these important aspects forward. So that's the last request I have for you. Now you and your team form part of this cog here to drive the iStruct-D wheel forward. So thank you again for the opportunity. It's a real honour to be able to be the president for this year. I really look forward to meeting as many of you as possible and learning from all the great things that are happening in you and your region. So thank you.